So, when I first taught this part of the unit, I thought that I was told that parallelograms were the only thing on the EOC, and then I learned that was not right. I learned that like all the quadrilaterals are on the EOC, which is just like another part of what makes this unit insane. So we're going to look at parallelograms first and just do some sample problems, but then we also have an activity. So today has two parts. It has a parallelograms worksheet, and it has a quadrilaterals activity. The quadrilaterals activity has 12 problems. The parallelograms worksheet has a little bit less than that, and then you have no notes tonight because this is the last part of this unit. So I think it is pretty manageable. The math for each of the problems are kind of like yesterday, where the math itself was easy to solve. The more important thing that you were practicing is just like recognizing what relationship is there. And again, the hardest part about this unit is just that there's so much information. So we really want to make sure that this unit, we are either every day going home and watching the new part that should be added to our cheat sheet, or we're going home and taking our notes and converting it to our cheat sheet. But the big important thing for this unit is we are all working on cheat sheets throughout the unit, making sure that the night before the test, like that cheat sheet is getting done for our test, right? Everybody's making a cheat sheet for the test. Nobody's going to go into this test blind without a cheat sheet. Yes. No new content after this day. So this is the very last thing on your cheat sheet. Yes. We have one more unit. The last unit is pretty short. It's trigonometry and statistics. And trig we do like a quiz testy thing for, and then stat I don't test you on. I just teach you some things and call it good. You can look, I think I've mapped out the days for the review. Our test is not until the 20th. Yes, it is for sure on the 20th. So our test is a little bit later than some of the other tests are. So we will be reviewing. The one nice thing about the EOC is that when I review for it, I say I've been testing you guys this whole time. As much as I can, I will show you guys how to manipulate calculators to do the test so that you don't have to remember everything. I will only tell you to recall things that you have to recall that a calculator cannot do for you. So when we review for the when we review for the EOC, I will say, hey, don't remember this? That's fine. Your calculator can do it anyway. So most of our review, instead of me forcing you to remember things, it's actually going to be me teaching you calculator tricks. Does that make sense? That's most of our review. Because I've already taught you the things, I'm not going to cram it down your throat in a short period of time. I'm going to say, hey, calculator fun, let's do it. And I'm going to teach you Desmos. Does that make sense? Okay. Yeah, the EOC is Desmos and calculator active. So the whole thing, which is very nice of them because Desmos makes that test a lot easier. Like to a ridiculous degree. It would be a much more difficult test if they took Desmos away. I will say that. The questions themselves are like good. And like can be difficult. Them allowing you to use Desmos makes the test a lot easier for you guys. So, okay, so let's go ahead and start looking at these questions. So the stuff that you'll do on these questions, you'll see that you can kind of apply them to the other quadrilateral shapes because the properties that were true for parallelograms are like true for the other shapes as well. So they'll work for both of the assignments we're doing today. So for this first example, you can see that the property that we're using here is that we have that consecutive angles, because they're right next to each other, so these are consecutive angles, and they are supplementary. So I'm going to go ahead and write that underneath, that the property we are using is that consecutive angles are supplementary So that's the property we're using. And that just means that two angles that are next to each other add up to 180 degrees. That's what that means. So we're going to say 10x minus 12 plus 72 equals 180 degrees. Consecutive angles are supplementary. So we can go ahead and combine like terms. Negative 12 and positive 72 is 60. And then we can subtract the 60 over 10x equals 120. And so x equals 12. And all they asked to do was solve for x, so we're good. The property that we use for the next one is that opposite sides, they're not only parallel, but they're also equal in length, or they're congruent to each other. So we're going to say that the property we're using here is that opposite sides are congruent, or you could write equal. It doesn't matter which word, congruent or equal. It doesn't matter which word you write. So here we've got 5x plus 5 equals 20. So for the video last night, each of those facts that we wrote about a parallelogram, each of those properties that we wrote about a parallelogram or those quadrilaterals, they all have an implication mathematically of like a different problem you could type, like problem type that you could solve. So here we'll go ahead and subtract the 5 over 5x equals 15, divide by 5, x equals 3. For this one, we have angles that are across from each other. So here we have opposite angles are congruent. Angles that are across from each other are opposite angles. Opposite angles are congruent. So we're just going to take them, set them equal to each other. 17x plus 8 equals 19x minus 2. So I can move the x's to one side. 8 equals 2x minus 2. Move all the numbers to the other side. 10 equals 2x. And then x equals 5. Now, I'm not done because they didn't want me to solve for x. They didn't say that was the purpose of the problem. The purpose of the problem was to find the measure of angle F. So once I know that x equals 5, how could I find the measure of angle F? Yeah. Okay, so if I find E, I would do 17 times 5 plus 8. So 17 times 5 plus 8. So that's 93. Okay, so this right here is 93. And then from there, how would we find F? Okay, 180 minus 93. And what does that equal? 87. Okay. And what property did we use to find that angle F was 87? What property are we using right here? So right here we were using that consecutive angles are supplementary. When you do your practice assignment, you do not have to write out the properties for every single problem that you do. The reason we're doing it on our notes is just so that we can see this is the math fact that we learned, this is how it works in our application. This is why we're able to do what we're doing. Okay. So the measure of angle F is 87 degrees. Final answer. Okay. The next one says, if x to g is 12, and e to g is 13x minus 2, x to g is 12, e to g is 13x minus 2, solve for x. Can't really read what I wrote there. 13x minus 2. So can anyone tell what property we're using on this one? Diagonals bisect each other. Right, diagonals bisect each other. Okay, so if this side is 12, what's this side going to be? 12, because that's what bisect means. It was cut in half. So we're going to have 13x minus 2 equals 24. So once we add the 2 over, we get 13x is 26. And so x is 2. All right, are we comfortable so far? Things are making sense? Okay. All right, the next one. This one is going to take you back to Math 2. You did this in Math 2, so it's probably been a while for most of you guys. So with this one, what I'm going to have you guys do is draw these lines from the parallelogram, draw these extra long. So we know, oh, that was not parallel. We know that the opposite sides are parallel. Because it's a parallelogram. So we're going to say opposite sides are parallel. Because it's a parallelogram. And then I'm going to draw this in marker so it doesn't get confused with the pencil. This right here. So what we have is we have two parallel lines and a transversal. If that sounds familiar from Math 2. We've got two parallel lines and a transversal. What do you know about the relationship between this angle and this angle? They're congruent, and what are they called? Not vertical. They're alternate interior angles, and alternate interior angles are the same. So we're going to say that this angle and this angle are the same. These are both 96 degrees. So this picture right here in particular seems to be pretty common with parallelograms, where they will give you one of the angles and then you'll use alternate interior angles specifically. Not all of the relationships from Math 2. That one specifically from Math 2 to find a missing angle. So let's draw the picture again because we marked it up. Let's just make sure we can kind of recognize what that picture was. So what they did is they took a parallelogram, they drew one diagonal in the parallelogram, and that diagonal was the transversal. And then they said, okay, if this is 96 degrees here, then this is 96 degrees as well, and that's because they're alternate interior angles. It's a very common problem in parallelograms. And it's because two parallel lines and a transversal from Math 2. It's just been a minute since you guys have done it. Okay? So two parallel lines, transversal, it's a Math 2 question showing up in Math 3. Now, they don't seem to use the other relationships. It's that one specifically. Okay? All right. We've got one more problem to do. They said here, we have a picture, they said find the lengths of the sides of the parallelogram, and they took the parallelogram and they put it on a coordinate axis. So the top and the bottom are kind of nice because those are just like straight left and straight, like straight across left and right. So if we wanted to find the length from A to B, what would that distance be? From -7 to 6 would be a length of 13, okay? And then what about the bottom? From C to D, that's 13. Okay, so those are the same. Okay. And then if we wanted to make sure that those two sides were parallel, we can compare the slopes, okay? So I'm going to say the slope of AB. What's the slope of a horizontal line? 0, okay. What's the slope of CD? It's also horizontal, so it's also 0. So they're the same length, they're the same slope. So they're parallel and they're the same length. That means it's probably a parallelogram, at least that side is not ruining it for us, those two sides. So we're going to go ahead and we're going to figure it out with the other sides. Now the other sides, we have slanted lines, and so we can't just count boxes, and we can't just look at the numbers. We actually have to do a formula. Does anyone remember the formula for finding the distance between 2 points? It's from middle school, I believe is when you learned it. It's called the distance formula. It's got a big square root over it. It's got a parenthesis, something squared, plus another something squared. Okay, x1 minus x2. Perfect. Okay. So the distance from B to C is going to be the square root of, and we just have to be consistent when we do this. So do you guys want to do top minus bottom, or do you want to do bottom minus top? Which way do you want to go? Top minus bottom. Okay, so we'll do 6 minus 4 squared, and then 5 minus -2 squared. Okay, so 6 minus 4, that's 2 squared, and 7 squared. We got 4 and 49, which is, yeah, 53, just square root 53, okay. All right, and then the next one we have from A to D. Okay, do you guys want to do top minus bottom or bottom minus top? Doesn't matter as long as we're consistent. Top minus bottom? bottom minus top minus bottom. So we'll do -7 minus -9. 5 minus -2. So we've got 2 squared again, plus 7 squared again. So we got root 53. Okay, so they're the same length. Oop, I wrote root 3 instead of root 53. Okay, and then do these have the same slope? Do they have the same slope? Yes. What's the slope? Can you tell? Yeah, it looks like up 7 over 2. Yeah. Okay. Cool. All right, so let's look at our properties sheet. Is there any other property that looks like it could be confusing? Anything else? Diagonals bisect each other, we're comfortable with. Are we comfortable with diagonals that are perpendicular? Do we know what perpendicular means? What does that mean? Right angle, so 90-degree angles. Sides that are equal in length, we know what that means. All the sides would have to be the same. So we might run into that. Okay, so one thing did I do this in the video? No? Okay. So, you can go ahead and add this onto the back of your sheet. You can add it to the back of your video notes. I'm trying to quadrilateral, quadrilateral, quadrilateral. I see square. Does anyone see any that say kite? If you look around the room. The activity, when you guys look at the activity, do you guys see any shapes that say kite? Okay. Okay, so I'm just going to remind you guys, one of the formulas that we learned, I reminded you of it last unit, but you might have forgotten, is that the area of a trapezoid is 1/2 multiplied by the height times base 1 plus base 2. And if I were to define the base, so this would be the height right there. This would be base 1, this would be base 2. If you want to know what the middle is, what this line is right here in the middle, this is the median, and the median is 1/2 of base 1 plus base 2, which kind of makes sense. It's just the average of the bases. Okay. Are there any markings on the isosceles trapezoid that are confusing that I need to explain. So this tells us that the top and the bottom are parallel. The top and the bottom are parallel. It's called an isosceles trapezoid because this side and this side are the same length. Since the two sides are the same length, these two angles on top are the same angle measurement. These two angles on the bottom are also the same angle measurement, but they would be different than the top. The top and the bottom together are supplementary. They add to 180. And then also, I didn't draw it in the picture, but the diagonals are congruent. The diagonals would be the same. Okay. Is there anything I can zoom in on? Any questions I can answer? Brains are okay? All right. So there are two things to work on today. One is the activity around the room. Another is a worksheet. The activity around the room is with quadrilaterals in general. The worksheet is specific to parallelograms. You can do whichever one you want first. So the activity around the room is on Canvas, and I'm going to give you a copy of the worksheet. So whichever one you want to start off with is totally fine, okay? If you want to start off with the activity around the room so that you get that out of the way, that's fine. If you want to start off with the worksheet and then just know that if you don't get to the activity around the room, you can do it at home because it's on Canvas, that is fine as well. Okay? Make sense? All right. So let me get these handed out.